So you want to know where there is a blank in the table, the field that is blank. So select customer ID underscore ID first underscore name last underscore name date of birth from customers where date of birth is null. Then remember your semicolon. So the system gives us this. Now remember that if you look at the original table, yes, this space is blank. Date of birth is null here, but there is also phone number. There's phone number, but the system, we didn't request for the phone number, and that is exactly what the system did. The phone number column was not requested for. If you want the phone number column, instead of all this that we are specifying here, we'll have just put star here. Select star from customer where DOB is null. It will give us everything. So if we have put star, what the system will have done is that it will have extracted this row for us. Customer ID is 4, gray, black, date of birth is null, then phone number is this. So please, I hope it is clear. If you want to compare, so arithmetic operators tool is very common in, is also very common in SQL. You can also compare. You want to get an amount greater than so. For example, your what do they call it in the financial audits now? Materiality threshold. All right, materiality threshold is 250,000. Okay, so you can say, okay, select all from invoice where amount is greater than or equal to 250,000. The system will go and give you that extra information for you. Select all from customers where customer that's correct. So this one is saying select all. So this one is saying select all from customers where customer underscore. Now this operator is not equal to 2. You can see it's a combination of less than and greater than. Less than and greater than. So that means not equal. Okay? Not equal to 2. So the system will give us information about, see, customer ID 1, 3, 4, 5. It has omitted customer ID 2 because that is what we said, we don't want. You don't want any other information about any other customer. So 1, 3, 4, and 5, that is what we want. It gives us everything. Remember we said all. So like we said, star in SQL means all. Star in SQL means all. So the system is going to bring all the information that we have asked. It will meet row number 2. So that is a very good demonstration of SQL. So for example, look at this. So we have a customer table here. Oh, let me share screen. That's the power of experience. I believe we can all see my my screen, my W3 school screen. Hello? Hello? Hello?
Hey, you, Mr. Akin.
Yes, can you see my screen? Can you see my W?
Yes, we can. We can see your screen.
Okay, great. So look at there is a customers table, right? Now, if you want to get every information or get that table retrieved, so you simply type that command, select star from SQL from customers rather. So I can delete this, and if you have it, I think I send it to everybody where I say practice. You can also go to your Yahoo, your email. So select star. So you can delete this and try it yourself from customers. Then remember I said, let me try to run it. It might go without that semicolon. It might not. Oh, fine, it went. This environment does not care whether you put semicolon or not. Remember I've said that before. So you have to, it will take practice for you to know what will go and what will not go. So it is a very big, it's a very large table. Okay, so you have 91 rows. So you can see. You can see. So who can tell me the primary key here? Is there a primary key on this table? Any suggestion?
Customer ID.
Okay, so
Customer ID.
So the customer ID is the primary key because that is what we can use to track each of the customer one by one. So this primary key, is it a surrogate key or a natural key? This
It's surrogate.
It's surrogate because there's nothing like one in real life. All right, there's nothing like 1, 2. You cannot map 1 to Alfred in real life. Okay, but let's assume this is America. If they are put social security number as customer ID, that's a natural primary key. All right, so this is a surrogate primary key. So we have the customer ID, we have customer name, we have contact name, we have address, we have city, we have postal code, we have country. So select all from customers is going to give me everything, all the table, everything about that table. Now let's assume let's assume I want to now say select all from customers where customer ID is equal to 1. Okay, let me put the semicolon this time around. So look at it now. I want information about a particular customer. So, and this is very important in investigation. So you already know the person you are suspecting. You already know the maybe staff ID you want to look for, or invoice number you want to, you want to investigate. So you can specify. Like I said, you must know the definition, the name exactly as it is in the database, or else the system will not take it. So I run my SQL. Look at what the system has done. I hope we are seeing. So you can see the system extracted just this guy, customer ID, Alfred Futeskiste, contact name, Maria Anders, address, city, postal code, then country is Germany. Now let's assume I'm not familiar with this stuff, and I type 92. Customer ID is 92. Remember, we have 91 rows. Let's see what the system will do. You can see it said no results. Now let me also try and put customer underscore ID here. If I type customer underscore ID, we already know that there is a customer ID 2. If I put customers underscore ID is equal to 2 here and run it, you can see it gives me an error message. Error 1, could not prepare statement 1, no such column, customer underscore ID. So it will reject it because you have typed what is wrong. Let me also remove this S. Let me remove this S and run SQL. So you can see it still rejected it. Error 1, could not prepare statement, no such table customer. Why? I have removed S. So that's why I said you cannot use SQL if you are not familiar with the tables of the organization you are auditing or you are investigating. So the first thing to use SQL is to familiarize yourself with the terminologies that are used to describe tables and objects in that table. All right, so let's assume, okay, select all from customer where customer ID is equal to 23. You can see the system just went and extract that exact information for me. Okay, let's assume I say select all from customer where I want to use city. Okay, I want to get all the customers from a particular city. So where city is Lille. Lille. Now, you will notice something now. It will not run. Why did it not run? Let me do a correction. Let me put this one in quotes. You know, because it is a word. Okay, it's word. So it's expecting me to show the SQL that what I am quoting is a word. Remember when we were doing customer ID, one, it didn't ask for, look at it now. It's, so there are some laws you must follow when you are doing SQL. If not, it is not going to work. It's going to be giving you error message. So when I type Lille now without any information, without quotation mark, it bans me. But the moment I type Lille and put it in quotation, it gave me, it extracted that information exactly. So so let me see that table again in all. Okay, let's say I want to see country. Okay, I want to see country Germany. So select all from customers where. Remember I said if you want to be specific, you use the where command. So where country is equal to Germany. Remember I said now that you are typing words, you have to put it in quotation. So then you can put your semicolon. Of course, this environment does not care whether you put semicolon or not, but there are some SQL environment that if you don't put semicolon, it is not going to run. So it takes practice for you to get yourself familiar. So select all. Remember I said this star means all. So select star from customers where country is equal to Germany. So the system will go, when you click on run SQL, it will go to the database. So this SQL is actually query, getting this information from the database. So it has gone to the database and has extracted 11 records for us. You can see all these, if all these customers, their country is based in Germany. So these are some of the what you information you can get when you are using SQL. So if there is an amount here now, okay, let me ask, okay, I already know, for example, let me pick this postal code. The postal code is 52066, 52066. Okay, so select all from customers. Remember, this customer is the name of the table, where postal code is 52066. Postal code is 52066. So I click on run SQL. You can see. So once you get the command correct, the system is going to bring you the information. Okay. Let me also again select all from customers. I want to see maybe there is a one postal code that is repeated. No, all the postal code are unique. Okay, I think I've seen 5022 somewhere. No. It's unique. It's unique. So let me pick another country where country is equal to let's say Mexico. I think I see Mexico there. So if I run the SQL, so you can see. You can see it brings up 5 records. 5 records. So all these commands can be used Okay, is there any null here? I don't think there's any null. Okay, there's no null in these tables. Okay, let's try that's not equal to that we did the other time and see where customer ID is not equal to 3. Great, it worked. So you can see it brought everything out. Then it has omitted customer ID number 3 for us. So all these commands are very important, especially when you are auditing. Okay. Okay, this is order table. So let's see, select all from orders. Select all from orders, run SQL. Great. So you can see it brought everything out. Now, what is the primary key in this table now? Will I have a contribution? What is the primary key? What is the foreign key? What is the primary key? What is the foreign key?
I think the order ID should be the primary key.
So the order ID in the order table is the primary key. Then customer ID is a foreign key. Employee ID is a foreign key. Shipper ID is a foreign key because all of them are actually on another tables. Customer table is there, employee table is there, shipper table is there, which means customer table, employee table, shipper table are linked to other tables. So you can see that is what we call referential integrity. So any change, for example, if you make a change on customer table now, any change you make on customer table, since that customer table is linked to this other table, that change will come here and manifest, cascade, it will appear here automatically. So you don't need to be coming table by table, line by line, and be changing. So that's that. So for example now, I was hoping that there will be amount here, but no problem. So let's say select all from others. Let's use where command again. So where order ID is equal to 10 is equal to 10249. So for practice, let me put this semicolon just for you to take note, because this is the standard. All right. So if you run SQL, you can see it will just go and bring you that exact information. Okay. Let me see whether it will recognize this other ID reference as a number. So what about where other ID is greater than 10249? Where other ID is greater than 10249? Let me see. I'm test running it. Great, it worked. So you know it's English. They wrote it in a way so you can see the form. It brought 184 record. Every other ID you have here is greater than 10249. So we are starting from 10250. So you can see the beauty of SQL. You can once you have a problem and you are looking for information, just know the code, the command. All right. So let's assume I want to find other ID less than 10249. So you can see there's only one, and that's 10248. So this is how SQL works. Let me see other details. Okay, so this is other details. Here, the other detail ID is now the primary key. Other ID says foreign key, product ID is foreign key. All right, then quantity is simply part of the attribute. So, for example, I can say, okay, I want information, select all from other details where quantity is greater than 12. Where quantity is greater than 12. So remember we have 518 records. So can you do this manually? You use the whole day searching. So you can do this with SQL and just click. If there's anything like that, there are 361 of them. You can see the system has brought it up for us. So starting from other detail ID number 5. Of course, SQL is more than this. So I've sent a lot of I've sent materials on SQL. Even these websites, w3schools.com, something you can use to learn so many SQL commands on your own. So because of our time limitation, we can only just introduce it briefly. This is the first course in OCA, Oracle Training, Oracle Certified Associate. Is the first course is always SQL. Please, do we have questions? Because I want to round up on SQL now. Do we have questions? Okay, if there are no questions, let's go back to our slides on database. So it's for us now to pick up from here. I've only given you an appetizer so that we'll take it up as a challenge. You have all the materials we need to start developing. And remember what I said, that in real life, in audit, I'm talking from practical experience, all right? You select command you need. Every other command that we have here, your job is just to check that the DBA has not abused those commands, all right? So as we are rounding up on databases, databases best practices that auditors should watch out for: identify and patch known and reported vulnerabilities. So are they doing vulnerability scanning? Are they patching the vulnerability discover? Install only the database features that are needed. Record database configuration and store securely. Why? In case there are unauthorized changes in the configuration. Okay. Review database security procedures and policies. Store copies of the media used to build Oracle database offsite. Consider physical location of servers. Consider physical location of servers. Monitor Oracle log files. That's self-explanatory. Retrieve the PS command. The PS command is used in Oracle to see virtually what everybody in the system is doing. So that if that kind of command should not be given to just anybody. Encrypt data transmissions, secure password transmissions on the server, secure password transmissions on the client. Consider using host-based intrusion detection system to alert you. Ensure no user has alter session and alter system privileges. Be aware of key files containing hashes, so your password files should be restricted. Audit database users activities, audit application database login, audit users database passwords. We know all this from application auditing. Change sys password. Now, there are two powerful IDs in Oracle. Number one, sys. That is the most powerful ID in Oracle. Number two, system. Followed, system follows sys in terms of power, in terms of ability, capability. So that's why you need to ensure their password is restricted and well managed. So you need to do audit questionnaire around those when they are doing Oracle audit. How are they managing those IDs? When I was doing Oracle training, when we got to this sys ID, the guy that was training us when he was telling us the importance of sys ID, so I knew it was very important. Then he was not telling us that the password is highly complicated. So I knew the way he was describing it, I knew that there's no way he can memorize the ID. So as an auditor, I started auditing him on the spot. So I asked him, as he just raised my hand, I said, "Sir, how do you now store it?" He said he stores it on his system. When he said that, I just smiled. If he was in a live audit, I will flag it. But since I'm a student in this case, there's nothing I can do. I just said that, because it's a cause for worry. So how are they managing a password as delicate as sys? So sys password management, system password management, audit user account for password same as username. Of course, that's not best practice. The password cannot be the same as your username. Audit user account for weak passwords, lock dormant database account. So once you are not using the account for maybe sometimes, specify on the system should remove it. Audit third party and homegrown applications authentication system. All these in-house software, they may be weak, and of course they are connecting to the database, so their vulnerabilities can be transferred to database. So you need to check the security on those systems connecting to the database. Audit use of all grants privileges. Grant is used to give rights. Audit the use of all drop statement. I've said it, every time you see drop, that means they've deleted the table. You need to stop there and ask questions. Use triggers to capture login events that are of interest to the IS auditors. Review and document backup and restore procedures. Are they backing up the database? Review and document recovery procedures. It's not enough to do backup. Are they testing whether they can get the information back from the backup? Because dust, cold temperature, hot temperature, somebody dropping the tapes could have even destroyed the information in the backup tapes. So you need to be testing whether you can do what they call recovery test. Can you get the information back from the backup tapes? Store backup media offsite. This one looks like common sense, but it's not common because in audit I've seen it, in several audits where backup and the production tapes are in the same physical environment. So don't assume that people are doing the right things. Audit the use of all alter statements, audit the use of create user, audit the use of create role, audit or create statements. Establish procedure to review audit log, audit all cease operations. Remember I said cease is the most powerful ID in Oracle. So you need to be concerned about what the DBA is using it to do. So this is the end of database audits. Questions? Questions, comments?